Okay, so we've got our data attached. Now, what we want to do is have a look at this data. So the first thing we're going to do is we're going to see if pulse was different by gender. So let's start by plotting our pulse by gender. You should see on the right-hand side you'll get a box plot that sort of shows females on the left and males on the right. And even just looking at that, the average or the median, as we see those thick blue lines in the middle of our box plot, they look pretty similar. So now let's run our t-test. So we get a t-test here. It tells us that it's the 2 sample t-tests. So that means it's not paired. We've got females and males. They're not the same people with 2 measurements twice or anything that would make it a paired test. And we get a t-value that's rather small, 0.4. Take it from me as a statistician. We've got a degrees of freedom that's close to our 200. We had 200 originally and we've lost some degrees of freedom when we've gone and estimated the means and carried out this test. And we get our p-value. And our p-value is quite high. It's well above the magic number of 0.05. And so it's got the difference in the means there. So the mean in the female group is 75 almost, and the mean in the male group is 74.46. So it looks to me like the p-value is not low, so the null hasn't got to go. So our null was that our difference in the means is equal to 0. An alternative hypothesis, as it spells out here, is that the difference in the means is not equal to 0. So we're just going to stick with our null and say that our difference in our means is equal to 0. There is no difference in the means in simple English. But I thought for everyone it might be a bit easier. Sometimes looking at these outputs of the t-test is a bit hard to find the p-value. So I've just done some code that just says go get me the p-value from that t-test and then put it sensibly, so that if it is 10 to the minus 6, like lots and lots of zeros before we get to our first digit, then we can actually make it be rounded to 3 significant figures, or if it's very small, let it just put it as p less than 0.001.